to Module 8.1. In this lecture video, let's take a look at graphing numbers on the number line. So I got two examples here. One of them is plots these real numbers on the number line, and another one is plotting numbers on the number line involving with integers and inequality. So here I need to plot some fractions, so I'm going to go ahead and figure out what the decimal is for those fractions. If you look at the scale on this number line, you notice that there is, it's actually go by 0.5 at a time, because between any two whole numbers or integer, there's another line in between, so that's a halfway, okay, which is 0.5. So that make our scale 0.5 at a time. So let's see what the decimal is for 3 over 2. Most of y'all probably can tell 3 over 2 is 3 divided by 2. 2 go into 3 one time. All right, start with a decimal place, bring down the 0, so that will be 1.5. So 3 half is 1.5. 5 half is actually 2.5, because I will go into, well, 2 will go into 5 4 times. So starting my decimal place, bring down the 0, that will be 2.5. So let's plot these points. -3, okay, right here. 1.5 is going to be halfway between 1 and 2. I'm plotting my 2. 5 over 2 is 2.5, which is between 2 and 3. And I'm going to plot my integer 4. So basically here we're just plotting our real numbers, specifically rational numbers. Also, we're plotting a little bit of integers as well. All right, let's try this one. This is a very tricky example. We need to graph the set of numbers on the number line, and what we're going to graph here is all negative integers. Remember now, integers are positive and negative whole numbers. This time I just need to plot negative integers. All right, plot all negative integers. So that means the word integer itself means positive or negative whole numbers. So that means any decimals between my 0 and 1 or 1 and 2, between any two integers, is actually not part of my answer, because I just want integers only. Specifically, I want negative integers. All right, plotting all the negative integers greater than or equal to. So with the equal to -5, that means my starting number got to be -5. All right, greater means number to the right of -5. So the next greater integer, okay, is -4, -3, -2, -1. But when it comes to 0, I actually cannot plot here, because the problem wants me to only plot negative integers. So these will be the only 5 number I will plot. Because 0 and everything to the right are integers, but they are not negative integers. Okay, so I do a little bit of plotting here for the purpose of let you see the number line, because when it comes to the number line, numbers on the left is always smaller than numbers to the right. So small numbers are always on the left. Larger number is always going to be on the right on the number line, because that actually can help me comparing between any two numbers. Okay, either it's integers or rational numbers or decimals, we can actually compare them. So here are your list of symbols for equality and inequality. All right, so this symbol right here, right now the textbook called them less than. If that's assuming if we read from left to the right, that will be considered as less than. Read from left to the right, this is greater than. And we also have lesser than or equal to, or greater than or equal to. Okay, so all these symbols, okay, the way they're being named is assuming we read from left to the right. when we get to module 9, if you ever got to take Math 108, when it comes to module 9, I will show you how to read inequality from the variable. Okay, we can actually read inequality from the left to the right or right to the left. Okay, but for right now, we're going to read it from left to right. So let me just do a quick comparison here. I'm going to start out with the 3.2 compared with -6. 3.2 is actually to the right of -6. All right. So kind of let me, I was going to try to steal this number line here, but I can hand draw it as well. Oop, I'm clicking too many times. It froze it up on me for a second. Let me kind of just draw it by hand for a moment. So if I have a number line, I'm going to put a 0 right here. 3.2 is going to be to the right of 0. -6 is to the left. So as you can see, 3.2 is to the right of my -6. So that made 3.2 bigger. So I will use this symbol because the open end always going to face the larger number. So we can read this as 3.2 greater than -6. All right, let me redraw this again for the -12 and -13. So let's say 0 is here. The place to the next integer to the left is -1, -2, -3, so on and so forth. So that means I got to reach -12 first before I will keep on going left to reach -13. So that means -12 is to the right of -13. So that made -12 greater than -13. Okay, so basically there's a lot of different ways to comparing two numbers. One of the ways is simply saying the number to the right is always going to be bigger than the number to the left on the number line. All right. Back in Module 2, we learned how to compare two fractions before. So the way we did back in Module 2 is to find the least common denominator between the two fractions. Then we're going to find its equivalent fraction so we can compare the numerators. So 5 will go into the 15. It will need to increase 3 times, so my numerator times by 3. And we will talk about this in a different video. -4 times 3 is -12. The other denominator, 3, to become 15, got to multiply by 5 or go into a 5 times. So my numerator do the same thing, which is -10. So now I'm comparing between -12 and -10. -10 is actually to the right of -12. So that will make the -2/3 or the -10/15 greater. So I'm going to have my open mouth facing the larger one. So that means -4/5 is less than -2/3. Now if I want to read it the other way, I can say -2/3 is greater than -4/5. You can read it that way as well. All right. So here we got plotting real numbers. We can plot integers on the number line. We comparing numbers here. And let's go ahead and talk about this concept. That absolute value, you learned about absolute value before. What absolute value is representing is the distance on a number line. It's a distance of a number, or is the distance a number is from 0 on the number line. Okay? In other words, absolute value is about distance. There's no such thing as negative distance. That's the reason why, if you can recall, whatever coming out of the absolute value is always positive, because absolute value is talking about distance, okay, on the number line. So my symbol absolute value of 4 is going to equal to +4. So if I have an absolute value of -4, my answer will still come out of absolute value to be positive. Why does the answer got to be positive? Because it absolute value representing distance, okay, from 0 on the number line. All right, simplify the absolute value on the left of the given expression, which is negative absolute value of -7. So let me kind of begin to show y'all this real quick. Before I'm going to do this problem, I want to think back. I would like you to think back on, think back on something called the identity property. Identity property for multiplication. For any real number a is always 1 times itself. So that means, for example, if I simply have a number 2, it means 1 times 2. So we talk about this back in, probably back in module 1 when we mentioning the identity property for multiplication. Every number is always times by 1. When we begin to talk about fraction, that's when we say every number is always over 1. That's when we're dealing with fraction. So the reason why I'm mentioning this right now is, what happens if I have a negative number? A negative number means -1 times that number. And you can actually think of it this way. So this negative absolute value of -7, between the negative sign and the absolute value sign, there's actually a 1 times right here. So this problem is actually being viewed as -1 times the absolute value of 7. So just looking at the absolute value of -7, that will actually give me my answer as +7. Whatever comes out of the absolute value is always positive. But in front of it, I still have my -1 times. So -1 times 7 will give me my answer as -7. All right. So now determine if the value on the left is less than, greater than, or equal to the value on the right. So this negative absolute value of 10, again, this negative means -1 times. All right. Whatever comes out of absolute value is always positive. So absolute value of 10 is 10. But with the -1 times still in front of it, that will make this expression -1 times 10, which is -10. So the left side turns out to be -7. Remember now, it's -7 is not because absolute value of -7 is -7. Absolute value of -7 is +7. The answer is negative because there's a -1 times in front of it. Absolute value of 10 is 10. With a -1 time in front of it, that will be -10. So I got -7 and comparing with -10. So on the number line, excuse me, if you really think about it, -7, you know what, let me go back up here to this. -7 is actually to the right of -10. So that made -7 greater. So that means this problem, the negative absolute value of -7 is actually greater than negative absolute value of +10. Okay. All right. So what happens if I simply put a variable x inside the absolute value? So what this question is asking is, what can this number inside the absolute value be in order for that number to come out the absolute value to be 26.2? Well, as we know, whatever come out the absolute value is always positive. So that means, let me go back up here real quick. Just like what I wrote here, absolute value of positive come out to be positive answer. Absolute value of a negative of the same 4 come out to be a +4. So that tell me inside the absolute value, I can have a positive 26.2 for this problem, or I can have a negative 26.2, because absolute value of negative 26.2 will still come out to be positive 26.2. Sorry. absolute value of a positive 26.2 will still come out to be positive 26.2. Okay. So that means inside the absolute value itself, I can have a positive and I can also have a negative one. So this very last question here, what can I put inside the absolute value here in order to come out to be a negative 35.8? Well, if you know whatever come out of the absolute value is positive, then how can it be negative 35? So you just can't, whatever come out of the absolute value is always got to be positive. You just cannot be what? Be a negative. So this problem, I have no solution. No such thing coming out of absolute value is ever a negative. Okay, so this problem is no solution. So in this lecture video, we quickly talk about the absolute value, comparing numbers, and we also plot the integers or real numbers on the number line. All right, that will conclude this quick lecture video. Thank you for watching.